Okay, I mentioned to you last week that I wanted to start this treatment of advanced hydrology and water resources management by introducing first a case study. Because I want to give to you an example of what water resources management problems are. And I think that the best way to do that is to refer to a case study, to a real case study, which is referred to this region where we are starting, the Emilia-Romagna region, and refers to a problem that is compelling. It's an important problem, but at the same time, we could say that it's not really critical, because you will see why. And let's say for now that this is not a real problem of water scarcity for people. It's a problem of water scarcity for agriculture. So it's not a problem of securing water for people, it's a problem of securing water for agriculture. But you will see that nevertheless, from an economical point of view, this is a really compelling, important problem. And therefore I just want to make an example. And of course this is something that it's not likely that I ask in the final examination. It's just an introduction. It's descriptive, as you will see. What is important to you is to pay attention to some order of magnitudes, some practical aspects, and of course I could ask some questions related to orders of magnitude at the final examination. So it's not irrelevant for your final examination, but it's extremely relevant for introducing the course, the problems, and for your formation. So it's something that I think it's worth introducing. It will take about 40 minutes. So this refers to the Emilia-Romagna region, as I said, and I mentioned to you that it's a compelling problem. But first of all, let me introduce the reason where we are, you already know it. This is a presentation that has been done abroad, so I wanted to give a very detailed introduction of the behavior of the region. I won't give so many details to you. Just let me summarize some main features. And the main features which I would like to talk about are related to water resources management. How is water secured in this region? It's mainly secured for all the uses from groundwater, from wells that are located in the flat part of the region. The flat part of the region is the upper part, the northern part. The region is bounded by the Po River at north, as you may know. The southern boundary is the divide of the Apennines. On the east we have the Adriatic Sea, and on the west the boundary is tracked by one river, which I don't remember if it is not the Trebbia, anyway, I don't remember the name of the river, but on the west part it's limited by a river, and we have on the west part the Lombardia region, which is another flat region. As I said, water resources is given primarily by groundwater resources, but there is also an important component that refers to surface water, and in particular we take surface water in this region from the rivers that flow in the Apennines, from the Apennines to the Po River. You see that the river network is mainly oriented in the south-north direction, from the Apennines to the Po River, and then we have the Po River in the north. And so we take water from the Apennine rivers, and this is high-quality water because it's generally clean, with some exceptions, as you will see, but in general this is a water of good quality. And then we take a lot of water from the Po River for irrigation. The water of the Po River is not good quality, as you may know. It's somehow improving. It started to improve in the last decades, but still the quality of the water of the Po River is not good for civil use. It can be used for irrigation, well, some people say that even for irrigation is not really a good thing to use it, but it is used, and it is used after controls, of course. So it's controlled, but used for irrigation. So these are the main sources, which is important to keep into account. For groundwater, you already know that there is, especially in the eastern part of the region, there are some concerns related to overexploitation, which may lead to soil intrusion from the sea. So, you know, talking about groundwater in this region, there are some concerns. Also, there are relevant concerns related to the possibility that groundwater is overexploited, and therefore the possibility that groundwater may diminish in terms of availability in the future, because we are observing, it's not a clear signal, but we are observing some decrease in the groundwater level. It's not a clear signal because there are some wells that are clearly overexploited, and we observe the level that decreased over years, but there are some other places in the region, many places, where we didn't observe a clear signal of decrease of groundwater level. However, there are some concerns because, you know, to get an interpretation of groundwater dynamics is extremely difficult. While it's quite easy to get an overview of the dynamics of the river flow, because you can see it, and especially you can see the environment, you can see the river, the geometry of the river. When you talk about groundwater, you talk about a flow that takes place in a media that is not observable. We cannot observe directly what happens underground. Of course, we can make some surveys, and we can derive indications, but they are very local. While porous media and groundwater are extremely heterogeneous. So it's difficult to get a clear picture of what is happening underground. And therefore, you know, there are some people who say that indeed, basing on some observations and basing on some analysis of the groundwater age, some people, some scientists, are convinced that we are currently using a groundwater that is extremely old. And if it is old, it means that it's not immediately renewable. If we are using a groundwater that is 200 years old, this means that it will take about 200 years to get it restored. And therefore, this is a reason of concern. And therefore, there were many attempts in the past to try to reduce groundwater exploitation by favoring other sources like surface water. Now, what is the practical need? The practical need is to meet the requirement of the Water Framework Directive, and this is an important issue that you have to take into account. The Water Framework Directive, also called the Direttiva Europea delle Acque in Italian, also called European Directive number 62,000. This is an important European directive. First of all, what is a European directive? It's a European law that must be met by the member states by a given deadline. Like in this case, it's for water quality. It deals with water quality, and the European directive set limits for water quality to be met by 2016, so the day after tomorrow, basically. In 2000, and member states, when a European directive is issued, are required to adopt the directive by issuing a national law, because the European law is not immediately in force in state members. What is in force in Italy, for instance, is the national law. So in order to make a European law in force in a member state, the member state must issue a national law. So the European directive calls for adoption, and adoption is done through a national law. And member states are obliged to meet these requirements, to respect European directives, and if they do not, they are fined. When we talk about European legislation, you have to take into account that it's something that it's not really clear, I would say, and also not really trained. So there were already cases in which the European directives were not met by the member states, and like for emission of greenhouse gases. And it's not immediately easy to find a member state if the European directive is not met, because in some cases member states may have valid reasons not to meet it. But in any case, for water quality, this is a very important directive that you have to know. It's available online if you're interested, but basically what the directive does is, as I just anticipated, to fix some parameters for water quality, because the aim is to reach an acceptable state of water in terms of quality. And I'm talking of water, groundwater and surface water, everything, to reach an acceptable state of water by a fixed deadline and in all Europe. Of course, this is a feature, a prominent feature for a continent like Europe, to make sure that the environmental quality is at a reasonable level. And therefore the aim in this case is, again, to set standard targets for water quality. And the way in which we set a target for water quality is to define some water quality indicators, like, for instance, concentration of organic matters, which should not exceed the given limit. So some water quality indicators are identified, and targets for these indicators are fixed by the directive. A relevant question, where I said that the European Water Framework Directive applies to all the waters, but of course a practical question could be, what do you mean by all the waters? Do you mean also the water in very small canals, or just significant volume of waters? This is a relevant question. And of course the directive applies to significant water bodies. What is a water body? Is a, let's say, an assigned amount of water. So you say, if the amount of water that is stored in a water body is exceeding a certain limit, to me, the water body is significant. So the European directive applies to significant water bodies, because of course you can't apply water quality requirements to everywhere, because you have to monitor it, you have to take measurements. So you can't apply the requirements everywhere. You have to specify where the requirements apply, because therein, in these places, you have to monitor the water quality. So member states are required to monitor the water quality. So the first step of the directive was to ask the European state members to identify the significant water bodies, and some indications were given, some quantitative indication. And therefore all state members, and Italy included, identified the significant water bodies. And basically they are river, lakes, and groundwater bodies. And in those places, in those water bodies, member states are required to put monitoring into practice. The first step is to measure the water quality. And it's relatively simple, because you just go there, you take a bottle of water, and you bring the water to the lab to analyze the quality, and in particular to analyze the indicators of water quality set out by the European directive. Let me say that the European Water Framework Directive was adopted in Italy through two national laws. The first one was what we call the Decreto decreto legislativo means a decree, a law decree of, I don't remember if it was a decree of the president of the government, of the prime minister, or a decree, decreto legislativo is not a decreto del Presidente del Consiglio dei Ministri. Anyway, this is a detail that is concerned to law, doesn't concern us. And this law was the decreto legislativo number 152 of the 99. It was issued in 99. You may notice that it was issued before. It's 152/99. You may notice that it was issued before than the Water Framework Directive. The reason is that there were already some anticipations of the Water Framework Directive that were known to the member states, and therefore Italy could issue the national law in advance. But this national law was then substituted by another one, which is again another decreto legislativo, which is the number 152, 2006, same number, different year. So this is the running law, the law in force now in Italy, to adopt the Water Framework Directive. This decree contains all the indications by law, even by law, to meet the expectation, the requirements of the Water Framework Directive. It is called in Italian testo unico in materia di acqua, which means unique text regarding water. Good. So, what's the problem here? The problem is that, as you will see, that the requirements of water quality are currently not met in some significant water bodies of the region, and therefore, if they are not met, actions are required to meet them by 2016. And an intermediate step was fixed for 2008. And in order to improve the water quality, the most relevant option, the most immediate option that you have is to increase the water quantity. Because if you have a given concentration of like organic matter or contaminant, in order to reduce the concentration, the most immediate action that one can take is to increase the water flow so that the dilution increases and the concentration of the contaminant decreases. So you can see that water quality requirements have a direct implication on water quantity. So a direct implication in water resources management and in particular water resources exploitation withdrawal. Because especially for rivers, just 1 second, especially for rivers, the problems in terms of water quality are given by the fact that we are taking too much water from the river. So we have to reduce the water withdrawal from the river. So there is a direct implication in water quantity. I would say that all the other things I already introduced to you. And of course, this problem of water quality are especially exacerbated, are especially relevant during summer. And just a final comment, to increase the release of water in the river, so to decrease the water withdrawal, so increasing the water that is left in the river, means to meet the environmental flow requirements, what is called in Italian the flusso minimo vitale. So, of course, there is a direct implication, a key is missing here, there is a direct implication on the computation of the environmental flow requirements, the flusso minimo vitale. What is the flusso minimo vitale? What is the environmental flow requirement? The environmental flow requirement is defined as the minimum amount of water flow that is necessary to preserve the ecosystem of the water body. Again, The environmental flow requirement, or in Italian the flusso minimo vitale, is defined as the minimum flow for the river to preserve the ecosystem, the aquatic ecosystem, like to preserve the life of fishes, to preserve the wealth of the plants, of the riparian vegetation, and so forth, to preserve the quality of the river. Beware that when the flusso minimo vitale environmental flow requirement, the concept, was introduced then in the 60s, about, let's say, 40 years ago, 45. Before that, there were no concerns related to the opportunity not to take all the water from the river. So people were not concerned when they projected a water withdrawal, they just took all the water. And then they realized that, of course, this is an action that has a relevant environmental impact that induces the death of the ecosystem. And therefore, they started to be concerned. The environmental flow requirement was first mentioned in the European sheet of water, Carta Europea dell'Acqua, which was issued in 1968. And it was imposed by law in Italy only in 1989, but was not respected since then in many water withdrawals. Why it is not respected? Because, of course, when you really need water, and you need water for people, for agriculture, it's difficult to meet the need for environmental flow requirements. And in many rivers in Italy, even now, it is not met, it is not respected. It is not respected in a clear way, in a transparent way. People just say that there is not enough water, and therefore they just take all the water that is available. And therefore, the concept of the environmental flow requirement is very relevant for us, because it has a relevant implication on water resources management, very relevant. It may diminish the amount of water that you can take from a river of 50%. It's not really in the critical season, of course, during summer. So it's not really a nuisance. It's not really something that is not relevant. It's very relevant for water resources management. And this implies that it's not easy to be able to release it. And another issue which is very much important, it's not easy to monitor if water managers release the environmental flow. It's not easy at all. Because, how can you monitor it? You must send a person downstream to check. But of course the check is very local. It's just downstream. It happens maybe once in a while. It's not a continuous check. It's difficult to be able to set up a continuous check. In principle it would be possible, but it takes money because you have to install some electronic devices, automatic devices, so it's not easy to monitor. So in many cases, indeed, we don't know if the environmental flow is released or not. So this is a practical need, basically, to meet the requirement of the Water Framework Directive for the Emilia-Romagna region, while, of course, preserving the water uses. And as you will see, we have some water in the Emilia-Romagna region, but not plenty of water, especially during summer. Some historical background. This is a map of Italy some millions of years ago, 100 millions of years ago. And you will see that in place, instead of the Emilia-Romagna region, instead of the Padana plain, there was a gulf, a very profound gulf that was filled by sedimentation induced by the Po River. The Po River transported sediments from the Alps and the Apennines, and these sediments were induced siltation of this roof. And keep in mind that the amount of sediment transported by the Po River is far by negligible. Even today, the delta of the Po River progresses in the Adriatic Sea of about 30-70 meters per year. So it's really something very, very important. And in the past, when rivers were not drained, the deposition went even more rapidly. So this is really an important amount of sediments that is transported by the Po River. And the sediments come from the erosion of the mountains. Mountains that in turn are still lifting, because you know that the tectonic activity in the Alps is still very relevant. So the Alps are still raising. And also the Apennines, even if at a lower rate, the Apennines are older than the Alps. And therefore, you know, if the Alps are lifted, there is a compensation. When you lift a mountain, you increase the energy of the water flowing on the slopes. And increasing the energy, because you increase the energy, because you increase the potential energy. So you increase the velocity of the water, and also the erosion is increased to compensate the lifting of the mountains. So the Earth tends to be a perfect sphere, but there are tectonic activities that lift the mountains, and then erosion compensates. So this is a process that is quite normal. But what happened during the siltation of the Padana Plain was that the Padana Plain became a marsh, a huge marsh, palude. And keep in mind that in order to seed on the plain, the Po River changed its course many times. Because what happens when you have to fill an hole, like the Padana Plain was, is that you start by the sedimentation in one place, and then this place gets higher. So the river starts flowing in a place where the riverbed gets higher. So once the riverbed is raised, if a flood occurs, the river is diverted. The river just goes in another place which is lower. So this originates a continuous change of the course of the river. And this happened in the past. In fact, we talk about old riverbeds of the Po River. In Italy we call them paleoalvei. And this process was basically interrupted by humans. Humans have the convenience that the river doesn't change course. So the humans basically imposed to the Po Rivers a fixed course by building levees, and this in some places provoked the increase of the height of the riverbed, even at a higher altitude than the surroundings, which was compensated by excavation, etc. But it's just an invention of human to keep the river in the same place. And the natural tendency of the river is to change. And as I said, a huge marsh was originated, even because, you know, if you don't build levees, when floods occur, water, of course, floods everywhere and stays everywhere for a long time, so originating marshes. It was next. It was starting from the Etruscans that people started to drain the Po River, to build levees, to get it fixed, and they also started the reclamation of the Padana Plain. And it was an immense activity, because in order to dry a marsh, what you have to do is to dig channels in order to evacuate the water, to bring to keep the land dry. And it's a difficult challenge, because when the slope is very reduced, and of course you have a very very small slope in a place that was filled by siltation. When you have so long slopes, it's indeed very difficult to design a drainage network because you have to be very, very careful. And also there are some places in the Padana Plain where it's not possible to drain by gravity because the altitude of some parts of the Padana Plain doesn't allow water to spontaneously flow to the Po River and the sea. So in some cases, the draining was mechanical. It's still mechanical. And this is what in Italian is called bonifica hydraulica, and reclamation of lands in English. Now, with the development of agriculture, this drainage network is also used to irrigate the lands in the summer. And given the high quality of the soils, the Padana Plain is intensely cultivated. A lot of agriculture has been exploited in this region, and agriculture needs irrigation. In order to give you an idea of the importance of this region, let's consider that in the Po River Valley, the whole Po River Basin, which of course is more extended than the Padana Plain, but in the Po River Basin it is produced 40% of the national gross product of Italy. We call it prodotto interno lordo. So 40% of the national gross product of Italy is produced in the Po River Basin. And a good percentage of this is produced in the Padana Plain for agriculture and industry, which means that a lot of water is needed there. And keep in mind that when we talk about water needs connected to economics, this is an important issue because sometimes we tend to think that the important water is water to drink and water for rivers and environment. But water for agriculture and water for economics is still water for life. So when we talk about economic implication of water resources management, we don't have to consider that these implications are lower priority with respect to environmental implication. It's a high priority implication, the economics of water resources management, because economics means society, means well-being of people, means wellness of people. Economic is not just richness, it's also richness, but it's important also for the survival of people. Okay, now, some landforms. This is a river that flows from the Apennines. It's the Secca River, close to my place. I live in Reggio Emilia, so I'm close to who is from Reggio? You?
Yeah, and you. Yeah.
And you see that there are many draining walls along the river. This is a lake that is located close to the closure of the mountain watershed. And this lake is originated by a dam here, which has the purpose of withdrawing water for irrigation. So here we have water withdrawal for irrigation, and the lake was built in order to get a small reserve of water to be used during the summer. It's a small reserve, about 1 million of cubic meters of water, and it's very small. When we talk about dams, usually we talk about order of magnitude of hundreds of millions of cubic meters of water. Here is just 1 million. The depth is very reduced. And this is an important example, this lake, very relevant, because it's a very good example that if you, in water resources management, if you make some mistakes, the environmental implication will be very relevant. And here, the implication was that they built this lake in 1980. Just to be clear, this water withdrawal is about 5 centuries old, so it's very old. But in the past, the withdrawal was done without any barrage. It was just taken by the river because less water was needed. Now, in 1980, just to be able to get a reserve of water, they built the lake. And the lake was seeded in about 10 years. So people underestimate and they were very good engineers, but they underestimated the bed load of the Sequia River and didn't predict that the bed load was as high as to fill 1 million of cubic meters in 10 years. And what is even more important is that downstream, a massive erosion of the riverbed was triggered, because this is an elementary principle in river hydraulics. If you block the sediments, then downstream you have erosion of the riverbed, because there is no more compensation between the erosion that is done by the river flow, which has a relevant energy, and sedimentation. If you have a compensation between erosion and sedimentation, then the river gets in a situation of fair equilibrium. If the river is in a situation of a fair equilibrium and you block the sediments, then erosion prevails downstream. And what happened downstream is really impressive. There was a canyon was excavated by the river that is as high as 15 meters, and many bridges were compromised because of the lowering of the riverbed. So it's, it's an important issue. Just 1 second that I want to copy the file that I need. Okay, let me try to copy everything. Okay. Now what has been done here, they tried to restore the capacity of the lake by excavating sediments. And this is not an easy task, because to excavate 1 million of cubic meters of sediments is a massive work, it's a massive river engineering work, and what is more important, you don't know where to put these sediments. So it's not an easy thing to do. Sometimes people tend to say, well, if a dam gets completely siltated or silted, I'm not sure what is the correct terminology, then you can